Okay, what I want to point out is we'll do the problem certainly. I have access to an answer key to some of Wells's problems. And so what I don't have access to is what Wells's work looked like to do the problem. So what I claim over here, looking at the key from Wells's through my research, I found that they listed these two answers as an answer to this particular problem. And I have no complaint about it, but I don't like the way that looks. And I want to, further state that it's not totally correct, right? What I mean by that, plus or minus 3/2 is good. Plus or minus the fourth root of minus 3 is fine. But really, if you count them up, there's only 4 solutions over there. And I would know there's 8. But I want to go through the way Wells would have probably did the problem. And by the way, I'm not saying Wells doesn't know what else to do, and he certainly clearly does. Because the text up to this point, you're able to get all 8 solutions to this problem. But I want to tell you what Wells is doing over here. He's basically just factoring the problem. By the way, to get these answers, I mean. Relatively simple factorization, by the way. And then he says, oh, x4 has to be equal to 81/16. And then he says, oh, x is plus or minus. And the reason for that, if you raise a number to the 4th power, plus or minus, right, would just be positive. So it's going to be, I'll write that down. The 4th root of 81 is 3, and the 4th root of 16 is 2. And he calls it a day in that, and he certainly gets that, all right? Now, the other one I want to point out over here, this would be x4 equals minus 3. And Wells just like flippantly says, oh, x must be plus or minus the 4th root of minus 3, and he walks away from the problem, right? Now, how do I know that? I have access to a very sparse answer key, by the way. Some of the questions, though they don't put any work whatsoever down. They just say, oh, that's the answer, and leave it at it. Leave it at that. And by the way, it's great. I mean, it really is. What I want to do is I have to, maybe be a little more clear on this. But listen, if it's causing a great deal of pain, don't do it. But I'm going to write this over here. And let me write this down. And I'm going to factor it more. So I'm going to write down 4x squared minus 9. And this would be 4x squared plus 9. And that's the factorization of 16x4 minus 81. And then x4 plus 3 is going to be x squared plus 3i x squared minus 3i. All right? Again, problematic. There's no doubt about it. But the only easy one for me to do, believe it or not, is this one over here. It's super simple to do. What's x going to be equal to? Plus or minus 3/2. Why is that? 4x squared equals 9. Divide both sides by 4. Square root rule. What do you get? X. Whoops, I made a mistake. You know what? I should just erase that. I got a little confused myself. But anyway, 4x squared equals 9. Divide by 4. X squared equals 9/4. Square root rule, you get x equals plus or minus square root of 9, principal 3. Square root of 4, principal 2. And that's where this solution's coming from. But you know what? It's these guys that are tough to come up with, right? So I'm going to write them down, and let me put down one at a time. So 4x squared would be equal to minus 9. And what do you get there? X squared is equal to minus 9/4. Let me keep going. And what do you get over there? X equals plus or minus. Well, the square root of minus 9 certainly has an I in it and a 3. And these are principal, by the way. And the square root of 4 is 2. So we get 2 more solutions now, all right? So let me just point that out. We have 2 here. We have 2 here. Now, I got to do the other ones. And again, I hate to go there. Wells did not go there, though, all right? And by the way, sometimes I often, he goes to some pretty dark places in algebra. And this is one where he kind of, although we have a background in it, he decides he's not going to bother with it. But I'm going to write down this one first because it's the easiest for me to do. And that would be 3i. Then what you get over here, x would equal plus or minus the root of 3i. My trouble over here is that might look like a good answer to you, but you realize complex numbers have to be written in the form a plus bi, all right, where a and b are real numbers. All right, so what do you have to do over here? We've done in the past. I'll remind you what we've done in the past. You may not remember that, but I'm going to say the root of 3i is going to be equal to the root of a plus the root of b I, all right, with the understanding that root of a and the root of b are real number. What do I do then? Square both sides. You would get 3i. Then you would get a minus b plus 2 root abi. Then we equate. Well, I'm going to say over here, there is no real part to that. So I'm going to say, oh, a minus b must be 0. And the other one, the complex part, 3 must be equal to 2 root ab. All right? By the way, I know this looks difficult. It's not going to be difficult to do. The understanding here is a does equal b. So what do I get over here? I would get 3 over 2 equals root ab. 9 quarters is ab. 9 quarters is equal to, well, if a and b are the same, this is a squared. So then someone says, I wonder what a is. A is actually plus or minus 3 over 2. But remember this, the root of a has got to be a real number. So I have to select a to be 3 over 2, and that means b is 3 over 2. So the root of 3i is going to be the root of 3 over 2. You know what? If I'm going to write the root of 3 over 2 and be firm about this, this would be root 6 over 2. So let me write that down. It's going to be root 6 over 2 plus root 6 over 2i. All right? Now, someone's going to say, what are you going to do now? I still don't have the roots written down. Right? I'm going to erase all this business over here. I'm done with it. I don't need that anymore. But I do need to write x down now. All right, so I'm going to write that down for you. What's x going to be equal to? Well, it's equal to this. So let me write this down. It's root 6 over 2. That's a real number, by the way. Plus root 6 over 2i. What's the other one going to be? X is going to be the opposite of that. Root 6 over 2 minus root 6 over 2i. I got that done. Now, someone says, this is a lot of work. It is. But now we have, I'll point this out to you, we actually have 6 separate roots. All right? Now, when you study math further, what you're going to find out is real coefficient polynomials, all their complex solutions are going to occur in conjugate pair. I clearly see that with the first thing I wrote down. And what's the first one I wrote down? I wrote down 0 plus 3/2 of an I, and the other one's going to be x equals 0 minus 3/2 of an I. I definitely see it in conjugate pair. So what I'm going to claim over here is I'll be able to find the others. Now someone says, if I know these, do I know the others? You do. You just write down their conjugate pair, but I'm still going to go through it for you. What's the conjugate pair going to be? Root 6 over 2 minus root 6 over 2i, and the other conjugate pair is going to be x equals, by the way, that's the conjugate pair of that one. Let's do the other one, minus root 6 over 2 plus root 6 over 2i. And that's the conjugate of this one over here. I want to go through the work, though. And I realize that's painful. All right, so what do I get over here? I got this. So what does this mean? X squared is equal to minus 3i. X squared is going to equal plus or minus I root 3i. Now here comes the problem. Do you know what the root of 3i is? You do. We just did it. I don't want to do that again. And that's right over here. So it's root 6 over 2 plus root 6 over 2i. Here's the problem. I have to multiply that by I. So I'm going to point out what I'm doing over here. I'm taking the plus version I. I'm going to multiply that through. What are you going to get? It's going to be minus root 6 over 2 plus root 6 over 2I. I want to point out where that one is. That one is right over here. Now what am I going to do? I'm going to do this one. Let's do it. What do you get? Well, I'm looking at it. You're going to get minus root 6 over 2I plus, right? Because what I have? Root 6 over 2I squared, but minus is plus. Root 6 over 2. Do I have that one? I do. It's right over here. All right? So they occur in conjugate pair. But again, I understand what Wells is doing. Maybe it's from exhaustion. He doesn't bother listing them all. All right? But it's amazing that he'll list this one. I'm thinking if he's going to avoid the complexity of the problem, he should have just listed plus or minus 3/2. That's what we would expect from a modern-day algebra student. We would not expect all the work I just performed for you. Is the work interesting? Yes. Is it tedious? Yes. Can it be done with what we know? Yes, yes, yes. All right, let me remind you who I am, Ron Bannon. I realize I'm long-winded sometimes. My email address is Bannon, B as in boy, the @ symbol, NNON.US. And again, if you see something, please say something. Thank you.